I will now talk about some graph terminology, some terms that we use often when we are talking about graphs. And the first one has to do with the degree of a node. So I will first talk about undirected graph. So assume that I have an undirected graph G, and I take two nodes, U and V, in this graph. I say that U and V are adjacent or neighbors if these two nodes are connected by an edge. And then the degree of a node is the number of neighbors that a node has. Okay, so two nodes are neighbors if there's an edge that connects them. The degree of a node is the number of nodes it is connected to, not itself. Okay, so if a node is connected to three other nodes, its degree is 3. Think about it in the context of a social network. If a person is connected to 15 other people, then this person, the degree of this node for that person is 15. So if we look at this example here, for example, in this graph, A and B are neighbors. Okay? Or we say that they are adjacent. A and B are neighbors because they are connected by an edge. C and F are neighbors. C and F are neighbors as well, because they are connected by an edge here. D and G, on the other hand, are not neighbors. There is no edge that connects them. Okay? So then two nodes are neighbors if there is an edge between them. The other notion we talked about is the notion of a degree of a node. So here we're talking about for a node, how many edges connect to it, or how many other nodes it is connected to. So if we look at A, for example, I say, what is the degree of A? The degree of A is the number of nodes it is connected to. So we have, it is connected to B, it is connected to F, therefore the degree is 2. What is the degree of B? B is connected to A, this is 1, to F 2, to E 3, to C 4. Therefore the degree of B is 4. What's the degree of D? D is connected only to one node, C, therefore its degree is 1. What's the degree of G? Well, G is not connected to any, let me clean this. Degree of G, since G is not connected to any other node, its degree is 0. Okay? And it's completely fine to have a graph where every node has degree 0. So in which case, no node is connected to any other node. When we talk about directed graphs, the definitions change a little bit. So when we are talking about an edge in a directed graph, we talk about the edge from U to V, an edge from U to V, not an edge between U and V, an edge from U to V. And when the edge is from U to V, we say U is the tail of the edge and V is the head of the edge. Now we don't talk about the degree of a node. We split the degree into two notions. One is the in degree, one is the out degree. In degree is that the number of edges that are incoming into the node. So how many edges point to the node? That's its in degree. How many edges point out of the node? That's its out degree. Okay? So if I go look at this graph here, I say, for example, that if I want to ask what is the in degree of A, so I'm asking how many edges point to A. There are two of them, right? There's the one from B, there's the one from F. What's the out degree of A? How many edges are going out of A? There are no edges outgoing of A, therefore its out degree is 0. If I look at C, for example, the in degree of C, there are two edges pointing to it, one from D and one from E. Its in degree is 2. What's the out degree of C? There's one edge outgoing of C, therefore the out degree is 1. What about G in this case? How many nodes or edges are pointing into G? 0. How many edges are going out of G or pointing out of G? 0. Therefore the in degree and the out degree of G are both 0 in this case. The last two notions I want to talk about is the notion of subgraph and induced subgraph. So if G is a graph, we say that G prime is a subgraph if the nodes of G prime are a subset of V of G's node, and if E prime is a subset of G's edges. Okay, so let me take, for example, this graph here, and notice that the graphs are undirected here. I'm talking about undirected graphs. So if this is G and the nodes are 1, 2, 3, 4, and 5. So here's an example of a subgraph. So G prime, if I take, for example, a subset of the nodes 1, 2, and 5, one, 2, and 5. So this G prime that has 3 nodes, 1, 2, and 5, and an edge between 1 and 2, and no edges connected to 5, this is a subgraph of G. Another subgraph, for example, G double prime here, if I take 1, 2, 3, 4, and 5, 1, 2, 3, 4, and 5, and I take, this is a subgraph. If you look at it, the nodes are a subset of the nodes of G. The edges are a subset of the edges of G. If I take a graph of the form, for example, 1, 2, and 5 here, and I take this graph, 1, 2, and 5, 3 nodes, 1, 2, and 5, and an edge between 1 and 2, and an edge between 1 and 5, this is not a subgraph, because this graph has a node between 1 and 5. G doesn't have an edge between 1 and 5. Sorry, that this one here, 1, 2, and 5, has an edge between 1 and 5. But G itself does not have an edge between 1 and 5. So while the nodes of this here, G triple prime, the nodes of G triple prime are a subset of the nodes of G, but the edges of G triple prime are not a subset of the edges of G. So this is what a subgraph is. Just take a subset of the nodes, including, you could take all the nodes, take a subset of the edges, including you can take all the edges, then you get a subgraph. The other notion of induced subgraph is really defined by a subset of nodes. So here, when we want to take an induced subgraph, choose a subset of the nodes and take them. But once you take this subset of nodes, you have to take all the edges that connect them in the original graph. Okay, so let me give you an example of this. So let's look at this graph here, 2, 3, 4, and this is G. And suppose we have this connection here. So suppose I want to take an induced subgraph of 1, 2, and 4. What is the induced subgraph by V prime equal 1, 2, and 4? It will be this. If I take nodes 1, 2, and 4, and all the edges that connect them, this is an induced subgraph. Notice that G double prime, if I take 1, 2, and 4, and this one, G double prime is a subgraph of G. It is not an induced subgraph of G. Why is it not induced? Because I took the subset of nodes 1, 2, and 4, but I did not take the edge that connects 1 and 4. So this is not induced. Okay? So a subgraph is just take any subset of nodes, any subset of edges, you have a subgraph. An induced subgraph, it is defined by a subset of nodes. Once you take the subset of nodes, once you decide on that subset of nodes, you have no choice about what edges to take or not to take. You take every edge that connects 2 nodes in that subset that you took. This will give you an induced subgraph.